Thank you, Donald, and everybody else who caught that you couldn't hear me. My mic was not plugged in. So we're going to get started in about 2 minutes. It's awesome to have all you here. So thank you for joining us, Christella, Donald, Zamil, Michaela, Lilo. Why am I smiling? Pretty much because I forgot to turn my mic on, and that's a little embarrassing. We'll wait about 1 more minute, and then we'll get started here. And Marco, great to see you, buddy. This assignment today is designed to help you with the last 4 Khan Academy ones, the ones that are about x-intercept, y-intercept, and slope. So it should look very familiar if you've been working on Khan Academy. If not, after you go through this lesson, I think Khan Academy should be pretty easy. Marco, you can stop typing hi repeatedly. Alright, so we are going to get started here. I'm going to run through a few key terms first to really get us going, and then we're going to jump into that first problem. We talked earlier this year about a y-intercept and about an x-intercept. Specifically, they relate to solutions to our linear equations, our x and y equations. The y-intercept, if we're talking about a graph, the y-intercept is going to be the point where a line crosses with the y-axis. And if we're talking about solutions or equations, that point really means the value for y when x is equal to 0. The x-intercept is opposite. It's going to be the point where our line crosses with the x-axis, and when we talk about equations, they're really asking you for what is the value for x when y is equal to 0. I messed that up in your notes if you want to fix that. Alright, so for our first problem here, they ask us to determine the intercepts for each linear graph shown below. The y-intercept is something we talk about a lot. The x-intercept is related to that concept. For now, we're going to be finding both of them. For this first problem, and I'm going to go ahead and zoom in on that graph a little bit, so it's going to take a second to load as we zoom in. We're asked to find the y-intercept and the x-intercept for this first graph. So the key is really to understand vocabulary. Y-intercept refers to the point where our line crosses with the y-axis. So if that's the case, we need to understand where the y-axis is. And the y-axis, let me turn on my mouse highlighter. The y-axis runs up and down here. It's the vertical line. So the y-intercept is going to be where the blue line crosses with that y-axis. It's going to be this point right here that I'm kind of marking with a red dot on my screen. That point represents the y-intercept. Now for every point on the graph, they have an x and a y value. Here we see it's lined up on the y-axis with 2, so that tells me the y value is going to be 2. And if you all understand or remember that the origin is 0, 0, the very middle of the graph, if all we did was go up by 2, the y value is 2, but the x value is still going to be 0. Conversely, our x-intercept is going to be wherever that line crosses with the x-axis, and the x-axis runs from side to side. So the x-intercept will be where this blue line right here crosses with the x-axis. I'm going to put a red dot on it right there. And that point, that red dot where my mouse is over right now, represents our x-intercept. It's 7 units to the left. It's at -7, so it has an x value of -7. And because we didn't go up or down at all from the origin, it's lying directly on the x-axis, the y value is going to be 0. Now, sorry, I got to move that whiteboard out of the way. Give me 1 second. Alright, for the next one here, and hopefully this makes sense to you now. If you're at home, I'd encourage you to really just pause this video and do the next 3 on your own. If you're with me live, hopefully you're plugging these answers in before I'm actually plugging the answers in. So here they first ask us for a y-intercept for this next graph. The y-intercept will be where this blue line crosses with the y-axis. So this point right here where my green highlighter is. And we see that that has a y value of 100. And what we're going to start to realize, every single y-intercept always has an x value of 0. If it's the point where the line crosses with the y-axis, the x value has to be 0, and the y value here in this case was 100. Moving on now to the x-intercept. The x-intercept is going to be where this blue line crosses with the x-axis. So this point that I'm over right here, that's located at negative 250 for x, of course, because it's 250 to the left, and the y value there is going to be 0. We're going to keep moving now to the last two for problem 1. They're again just about y-intercepts and x-intercepts. So here we see for this graph, I'm going to go ahead and I'm going to put a red dot once again. This time I'm going to start, here's my x-intercept, here's my y-intercept. And I made that dot a little big. Let's erase it first. So let's put that dot a little bit better. And we see here for the y-intercept, it's sitting right here. It's right on a grid box, but that grid box is not labeled. I see that it sits between the negative 50 and between the negative 60, directly in the middle, and I know that directly in the middle of negative 50 and negative 60 would be negative 55. For every y-intercept, again, our x value is always going to be 0. We're not moving left or right. We just went straight down by 55 units, so it's 0 and negative 55 for the y-intercept. For our x-intercept, the next piece of this problem, that again is going to be where does this graph, this line, cross with the x-axis, and that happens right here where I'm putting a red dot where my mouse is. We see that sits exactly dead in the middle between 20 and 30, so that's going to give us an x value of 25. For every x-intercept, our y value is going to be 0, so there it's going to be 0. So we have a positive 25 at this point, 25 units to the right, and the y value is 0. It didn't move up or down at all. Lilo, I just saw your stop now, sorry. I'm going to keep moving, but feel free to say anything in the chat if you need me to pause, slow down, or explain something that's not clear. For this last one here, we'll go ahead, we're going to label the y-intercept. That's where this blue line is going to cross with the y-axis. We're going to label the x-intercept, and I'm going to quickly plug these answers in to keep us moving. For the y-intercept, it's 2 units above, so we're going to go with 0 and 2. And we've got a problem here today. That's the same problem as before. So you guys got lucky, one less problem. Negative 7 and 0. We'd already done that one. Alright, so that's x-intercepts, y-intercepts. That's the third assignment you're going to see on Khan Academy this week, is can you find those intercepts on a graph. So assignment 3 for Khan Academy. Hopefully that makes sense and you're ready to do that if it's not complete already. Problem number 2 is going to again deal with intercepts. They're going to ask us specifically to determine the intercepts for each linear equation this time. So now instead of getting a graph, we're getting equations. So I'm going to bring my whiteboard back into play. Give me a second to do that. And I'm going to also make the whiteboard a bit larger so you can see that better. Our first equation that we need to deal with here, which I'm going to highlight for a second, says 3x minus 4y needs to be equal to 12. So I'm going to copy that equation onto my whiteboard. 3x minus 4y needs to be equal to 12. And what we've learned from these graphs is if we need to find a y-intercept, which is the first thing this asks here, the y-intercept, if you recall from the graph, the y-intercept always has an x value of 0. So to find my y-intercept, I'm going to replace x with 0, because I know every y-intercept is really saying what is y's value when x equals 0. And the nice thing about finding intercepts is when you do 0 times 3, or when you plug in 0 for x, it eliminates the entire term. 0 times anything is nothing. It disappears. So finding intercepts is pretty quick and easy because it eliminates, in the y-intercepts case, the x term disappears, and now all that's left is negative 4y equals 12. If you think back with Mr. Neville last year peeling the onion, I want to get rid of that multiplied by negative 4. So I'm going to divide by negative 4 on both sides of the equation. A positive divided by a negative gives us a negative. And that tells us y needs to be equal to negative 3 if the x value were 0. So for this problem, our y-intercept now we know is 0 and negative 3. The x-intercept, of course, as we found that on a graph each time, the x-intercept was always telling us what value should x take if the y is equal to 0. Every x-intercept had a y value of 0. So to find the x-intercept, I'm going to take that 0 for y, plug it in for y, and negative 4 times 0 is going to give me nothing. That leaves just 3x on the left side of this equation. So our equation becomes 3 times x needs to equal 12. And I know that 4 is a number times 3, that makes 12. So instead of dividing both sides of this equation by 3, which would cancel out the multiply by 3, I'm just going to solve by inspection. Anytime the equation's simple enough, you know the answer, feel free to solve it by inspection or just looking at it. You don't have to write every last step out. So that helps me see that my x-intercept, in this case, the x value will be 4 for this equation if I turn the y value into 0. At this point, if you are with us live, I would encourage you to keep trying to figure out the next couple on your own. Hopefully you have pencil and paper with you and you can keep moving on to this next one for problem 2. If you're at home, I would encourage you to pause the video, try to do the next 2 on your own, and then come back and see what I got for an answer. We're going to make this whiteboard just a little smaller so we can see that second equation. And our second equation that we're going to work with to find x and y intercepts, this is 2x plus 5y equals negative 6. This is pulled directly from Khan Academy. You'll see these ones on the 4th Khan Academy assignment this week. So we have 2x plus 5y is equal to negative 6. And again, they're asking us to find intercepts. So I need to remember or understand that the y-intercept is going to be the y value when x is 0, and the x-intercept says what x value do we get if we turn y into 0. First things first, I'm going to replace the x with 0. 2 times 0 plus 5y equals negative 6. And that's going to be helping me find my y-intercept here by replacing x with 0. Anything times 0 disappears, so this equation really just becomes 5y equals negative 6. And I would divide both sides of this equation by 5. That cancels out the multiplied by 5, the coefficient of y. 6 does not get divided evenly by 5. If that happens, if you don't get a whole number with your fraction, it's okay to leave the answer as a fraction so long as the fraction has been simplified. Here, 6 over 5 can't be simplified any further. That's reduced as far as it could go. We got to remember a negative divided by a positive makes a negative. So in this case, we have a y-intercept of negative 6 over 5. Some of you might have negative 1.2. That's what happens if you do 6 divided by 5. That would also be okay. But in my case, I'm going to leave that as a fraction. I think that's a little easier than switching to a decimal. When you type fractions, there's a fancy way to put fractions if you go ahead and insert equation. But I think it's totally fine to write your fractions as you see me inserting it there. Just use that slash symbol to write the fraction. And we know that means the fraction with the number on top and the number on bottom. Hopefully that makes sense. We're going to now run through the other piece for number 2 here. If I'm going to find my x-intercept, that really says when y is 0, what does the x value get to be? So I'm going to replace y with 0. The trick you should be seeing at this point, I don't need to write 5 times 0. The whole 5y is going to disappear when I replace y with 0. So if I make y into 0, the equation simplifies just to say 2x is equal to negative 6. What number times 2 gives us 6? I know that 3 times 2 gives us 6. And I know I need a negative because a negative times a positive would give me a negative 6. So based on 2x equals negative 6, I can see x has to be negative 3. If I couldn't see that, I could have divided both sides of the equation by 2. Dividing by 2 would have canceled that out and get you the same negative 3 answer that I got by inspection. So that gets us the x-intercept there. It's negative 3 and 0. We're going to show one more example. We'll flip the whiteboard to the other half. And the last equation that we're going to work with, again, if you're with me live, try to do this on your own a little ahead of us. If you're at home, pause the video, try to figure this out before you see my answer. Carmichael, awesome to see you joining us, buddy. And really, really good work on Khan Academy this week from what I've seen. Answer my email, though. All right, y equals 5x minus 13 is our equation. The first thing we're going to find is the y-intercept. That means what value will y take if I turn x into 0. And there's something nice. You should recall the y equals mx plus b equations from this fall. If our equation is built with y all by itself, it says y equals. The y-intercept's just this regular number, the b, if you remember mx plus b, that's all by itself. I could plug in the 0 to prove that. I'll go ahead plug in 5 times 0 minus 13. I know 5 times 0 is 0. And I know that 0 minus 13 gives us negative 13. But again, whenever my equation is built in this y equals form, y is isolated all by itself, the y-intercept is the b, the regular number that's all by itself without the x. So there's 0 and negative 13. That's our y-intercept here. Now when the equation is in this y equals form, it's very easy to find the y-intercept. The x-intercept is a little more complicated. It's not obvious based on this equation, and it gets a little tricky when I plug y in with 0. So remember, x-intercept says the y value needs to be equal to 0, so I'm going to replace my y with 0. I'm going to draw my river here. Remember, the left side only had y, so now the left side of the equation is equivalent to 0. The 5x and negative 13 are both on the right side of this equation. I cannot combine them together. They're not like terms. And I want them on opposite sides of the equation so that I can solve for x. To do that, I'm going to get rid of this negative 13 by adding 13 on both sides of my equation. And that gives me 5 times x needs to be equal to a positive 13. Now this should look a lot more familiar. A bunch of you hopefully are sitting there saying divide both sides of this equation by 5. And that tells me x is equal to 13 over 5. So if I make y equal to 0 in this equation, the x value needs a value, not a whole number, a fraction that happens to be the fraction 13 over 5. If you did 13 divided by 5, you'll get 2.6. Some of you might have 2 3/5, a mixed number, but I prefer to leave mine as an improper fraction, 13 over 5. And the y value, of course, is 0. If you've got any questions about the y-intercept, the x-intercept, how to find them, now is probably the time to put them in the chat, or let me know after this video. That's the third, fourth Khan Academy assignment this week, and they're very much like what we showed there. We're going to keep moving now. Now we're going to move on to the part that talks about slope. Before we get into slope, I'm going to go back to the very top of this document. Encourage all of you to join me. Go to the top of your document. And we're going to refresh our memory on what the definition of slope is. Slope, we talked about some in this fall. You're going to talk about it a lot in 9th grade, 10th grade with math. It's because we're going to do a lot of relationships between x and y for the rest of our math lives. And slope always refers to the rate of change for these two variable equations. Slope says how much is the y variable changing by each time x goes up by 1 unit. And to measure slope, or to find slope, you can determine that value, how much y goes up for every 1 increase of x, by doing y change divided by x change. And the first problems we're going to look at have graphs. And when I look at graphs, I really think about y change over x change. I use this phrase, rise over run. Because what you will see on every graph, allow me to zoom out just a little bit, on every graph, the y-axis is the vertical axis. It runs up and down. So if we have a blue line like the one we see here that represents our x and y relationship, the up and down movement, the vertical movement for the blue line, is going to show us exactly how much the y changes by. That's what we mean by rise, the up and down movement. And run, the other piece, run refers to side movement, how much we go sideways, and that will tell us how much the x has changed by. So for every single slope graph that we're going to do, you're going to need 2 data points to measure your slope. I'm having a little issue with my screen tool, so give me 1 second to relaunch that so I can hopefully put dots on this graph and mark it up. Alright, so I'm going to need 2 points on this graph. If the y-intercept happens to be right on a corner of a grid box like we see here, I almost always use that as one of my 2 slope points. So I'm going to use this point right here that I kind of highlighted in red there. And then I'm going to follow this graph until it hits another corner of a grid box. And I see right here, this is not the only other point I could use, but I see a nice corner right here. So what I'm going to do is I'm going to count how much I had to move up by. So if I were at that first point and I went straight up and then I went straight sideways, how much did I have to go up by and how much did I have to go sideways by? I counted up by 1, 2, 3, by 4 units. So we'd say it went up by 4 units. And then I also went, and that's very messy, I'm trying to get better with this tool. And then I also went right, I see here right by 2 units. So the right value I've changed by 2 units. So that tells me when I try to find my slope out, let me just make that just a bit smaller so we can see. When I now try to put slope into this answer, I know that the y change, the rise, is up by 4. And I know that the x change, how much it went side to side, is sideways by 2. And I know when I go up by 4, the y value is gaining, and when I go right by 2, the x value is gaining. So both of those are positive numbers. 4 over 2 can be simplified. That slope could actually be simplified to 2 over 1, or you could even simplify that further just to say a slope of 2. And all that really means is that on this graph, every time we go up by 2 units, we go right by 1 unit. The y will keep gaining 2 units each time the x loses 1 unit. So hopefully that makes sense. Again, the big key for graphs, you're going to need 2 data points to measure slope, and you're going to measure rise over run. We're going to keep moving now on to the next one. I'm going to put 2 red dots onto this graph. Again, you can use any 2 points. I strongly encourage you, pick the points on the corner of grid boxes. It makes it much easier to count. That gives you whole numbers so you don't have to have halves or count quarters or thirds when you're trying to figure out how much it moves. So I see this red dot here. I keep traveling along my blue line, and the next corner of a grid box that I see here is that one right there. So these are the 2 points I'm going to use to measure slope for graph 2. I go to my original point, and I'm going to travel up as far as I need to go up, and I'm also going to travel over as far as I need to go over. And here we see that we traveled up by 1 unit, and we also traveled, so we climbed up by 1 unit. That's going to give us a rise of 1. And then we also traveled over, or to the right, by 2 units. So we have a slope of 1 over 2, or 1/2. If you really want to get fancy, you could call that a slope of 0.5. But we prefer to leave slope as a fraction, so it really tells us, hey, go up by 1 unit and go right by 2 units. Hopefully that makes sense. If you've got questions, put them into the chat. For our next 2 graphs, again, they're going to ask us to find the slope for these graphs. I'm going to need 2 data points for those graphs. So I look on this blue line, I'm looking for corners of grid boxes. I see right here is 1 good data point, and I keep traveling on this blue line. I could use this data point. That's fine. I'm going to actually keep traveling along, find another corner of a grid box. It keeps going all the way to... Oh, this is actually a tricky one here. So if you zoom in, you'll see it doesn't actually hit this corner. This is a meaner problem than I thought. You need to keep following this blue line. Oh, and Marco, bachelor's level just means it's getting a little more challenging. Master's means it's more challenging than that, and PhD's above that. They have to do with degrees that you get in college and beyond that. Thank you for the question. So the other data point, wow, this is a tricky one. The only other data point where it hits a corner of a grid box is way down here. Sometimes Khan Academy will give you these mean ones where the blue line doesn't have many great data points to measure slope with. But it hits this corner down here, it hits that corner up there. So it goes here, it's at 4, and travels all the way down here at -4. So I'm going to draw that big down line. But I know if it's going from +4 all the way down to -4, we must have counted by 8 units. No problem, Marco. And so if I went down, I'm going to call that a -8 units. This went down by 8 units, so I lost 8 units on the y. And then it also went over to the right by 1, 2, 3 units. And I'm going to call that a +3, because anytime you move right on the graph, that means it's gaining on the x-axis. So my slope here is going to be -8 for the y change. It's going down 8 units each time it moves right by 3 units. And certainly a more challenging one there to find. You'll see a few of those like that on Khan Academy and IXL. One last one to do here. You're actually going to find it a little easier. We see this line here and it hits quite a few good points. I see this corner here, so I'm going to mark a few points. You could use any of these. I see it hits this corner of this grid box right there, and also it hits this corner here. Any one of those would be great data points to use. I'm going to use these two, the y-intercept and that next one that I see. I see that it climbs down by 2 units. That's what I'm drawing here, down by 2 units. And then it also happened to move right by 3 units. So it went down 1, 2, and then it went right by 3. So I'm going to have a slope of -2 over 3. I'm going to zoom out as we clear out some of those red markings, and the big thing I want to emphasize here as we take a look at problem 3 before we move on. One thing that students tend to struggle with slope is to tell when the slope is positive versus when the slope is negative. And what you should notice here, our first two graphs, where the line moves up towards the right, up to the right, up to the right, they both had positive slopes. And the two graphs where they moved down towards the right, where the line traveled down in a rightward direction, we saw a negative slope. So hopefully that can help you tell the difference between positive slopes and negative slopes. We're going to move on now. It's still going to be talking about slope, but now they take the graphs away from us. I'm going to erase my whiteboard while this zooms back in on problem number 4. And for slope, I'm going to put a couple notes on my whiteboard as we get started on the 4th problem here. For slope, recall we define slope as our rate of change, and specifically we find that rate of change with our y value in the numerator, the top of our ratio or fraction, and the x value in the denominator, the bottom of that ratio or fraction. So I'm going to make that whiteboard a little bit larger. And when we take a look at problem number 4, now instead of giving us a graph, all they do is they tell us 2 points that the line passes through. So we can't visually count on the number line or the graph that we were using before. But we do have the coordinates. We know for point 1 on number 4 that our line passes through 1 and 0. And then we know for point 2, as the line keeps going, it eventually passes through the point with the coordinates 3 and 8. And it's important for me to remember here, whenever I list ordered pairs, we list the x value first. So these ordered pairs are telling us x is equal to 1 when y is 0, or x is equal to 3 when y is 8. And if slope measures rate of change and measures the y change on the top, it gets a little tricky because I really want to look first at what happened to the y value. How was the y value changing between the first data point and the second data point? And here I see the y value increases. It goes from 0 to 8. So that tells me that the y value, if it goes from 0 to 8, just gained 8 units. And the x value went from 1 to 3. That's also gaining units, but it only gained 2 units. So here I see for these 2 data points, the y value jumped up by 8 units from 0 to 8. So that's my y change for slope. And the x value jumped up by only 2 units. So that's my x change. My slope here is going to be positive 8 over positive 2. And we should know, I'll go ahead and put that 8 over 2, that's the slope. The y value gained 8 as the x value gained 2. Anytime slope is a fraction that could be simplified, we want to simplify that fraction as far as we can. 8 over 2 could simplify to 4 over 1. They're both even numbers. I divide them both by 2. And 4 over 1 actually just simplifies to a slope of 4, saying y will gain 4 each time x gains 1. Based on that, if you're at home on your own or you're with us live, you should be ready to do number 5. So I'm going to take my time as I get to number 5 here so that those of you who are with us live can try to figure out number 5 on your own. And if you're at home again, please pause the video, try to do number 5, that PhD level problem, on your own. I'm going to now scroll down to number 5. As I'm waiting, so you all can work through this, Marco, again, a bachelor's degree, if we're getting more specific, is what you earn at the end of college after 4 years. A master's degree is something you can earn after college. And a PhD, if you ever heard people have doctorate degrees, that's what a PhD really is. Some of them are medical doctors, but then lots of other people too who get doctorates in different things. It's just an advanced degree. All right, so for our last one, the 2 data points, it's a very similar question. They say a line is passing through these 2 points, -5, -10 is the first point it goes through, and the second data point it goes through is -1, +5. So if I'm going to determine the slope for a line that passes through those 2 points, I need to first measure how much the y changes by, and the y goes from -10 to +5. So it has to jump by 10 units just to get to 0, 5 more units to get to +5, so 10 and 5 put together means it jumped up a total of 15 units. And the x value travels from -5 to -1. Doesn't go all the way to 0, it just gets from -5, almost there, it gets to -1. So that's getting bigger to go from -5 to -1. We're getting closer to the 0. And it got bigger by 4 units. So I'm going to put a +4 there. So that tells me then that my slope, my y change over my x change, the y is gaining 15 units here, as the x is gaining 4 units, so this is another positive slope. Both y and x are gaining together. 15 over 4, they don't share any factors in common, so that fraction is as simple as it gets. There's no way to simplify or reduce 15 over 4. So I'm going to leave my slope as 15 over 4 as a fraction. I would not be switching that to 3.75, the decimal version of 15 over 4. Okay, so that gets us to the end of this assignment. And actually, for those of you who are here with us to the end, that's assignment 3, 4, 5, 6. It's most of your Khan Academy work this week. So if that's already done, you're in great shape. You've pretty much handled your math work for the week. If you haven't finished those Khan Academy ones, you're going to be in good shape now. I've made videos for each assignment, and you can always email me too if you got questions. If you have any questions, put them into the chat. Otherwise, I'm going to be signing off shortly, and we will see you guys tomorrow for Kahoot on Friday. All right, thanks again. See you later.